This is the basic Keynesian model. Our formula is our aggregate demand based on the expenditure approach. That's why we will call it the planned aggregate expenditure, which is equal to consumption plus investment plus government spending plus export minus import. We know that exports minus imports is called net exports. So I will talk about consumption. When we talk about consumption could be composed of two parts. The first part, which is C bar, we call it autonomous consumption. Why do we call it autonomous consumption? Because this is independent from our output. Plus, the second part is called induced consumption. What do you mean by the word induced consumption? This is dependent on our level of income. Therefore, the difference between autonomous consumption and induced consumption is, autonomous consumption is the minimum consumption that we need to consume regardless our level of income. Such as, in good days, we eat, we drink, we buy meds if we have to. In bad days, if we lose our jobs, we still eat, drink, pay for transportation, pay for rent, and pay for meds and go to the doctor if we have to. Consequently, this part of consumption is independent from our level of income. That's why we call it autonomous. The second part is called induced consumption. Why do we call it induced consumption? Because it depends on our level of income. For example, if you get a job that will give you 200,000 every year, you will buy a Ferrari. What if because of COVID-19 you lost your job? You will sell your Ferrari. Therefore, this part depends on your level of income. So we have here little c multiplied by our income. So this little c is called marginal propensity to consume, or MPC. What do you mean by marginal propensity to consume? For each one additional dollar of our income, how much we're going to consume from this additional dollar? It could be 90%. Consequently, we will save the rest, which is 10%. It could be 80%. Consequently, we will save the rest, which is 20%. Remember that when I talk about income here, I refer to disposable income. What do I mean by disposable income? This is our income after tax. So we get gross income minus taxes. It will give us disposable income. Therefore, let's assume that I get a salary, $100,000. Does it mean that I actually receive $100,000? No. After I pay taxes, let's assume taxes is $30,000. Therefore, 100 minus 30 is 70,000. So this will be my disposable income. So here, for simplicity, I'm not going to mention the letter D, and I'll write here just capital Y, and here it refers to disposable income. So let's draw it. On the Y-axis, we have our consumption. Our X-axis, we have our income. And we know that here, we have autonomous consumption. That's why we'll start from a value here. And we know that the sign here is positive. Consequently, we have upward slope. And this will be our consumption function. C equals C bar plus marginal propensity to consume, which is little c, multiplied by disposable income. And this will be our slope. So the slope here is a change in consumption divided by change in our disposable income. Therefore, we could say that our marginal propensity to consume is equal to change in C divided by change in Y. We know that our disposable income would be equal to consumption and saving. So anytime we receive an income, it's either we consume or save. This is the formula of our planned aggregate expenditure, which is consumption plus investment plus government spending plus export minus import. And we know that consumption could be classified as autonomous consumption, which is C bar, plus induced consumption, which is marginal propensity to consume multiplied by disposable income. So for each other item, such as investment or government spending or X minus M, we could have autonomous and induced. But for simplicity, I will change only consumption to be autonomous and induced, and all other variables will be only autonomous. And that's why I will put a little bar above each one of them. So we'll say that our planned aggregate expenditure is equal to C bar plus little c multiplied by disposable income plus I bar plus G bar plus X bar minus M bar. Then I would like to take all the autonomous components and put it in one category, which I will call it A bar. Some other textbooks, they call it E bar. Therefore, I will get here C bar plus I bar plus G bar plus X bar minus M bar. They will be together as A bar. Therefore, our planned aggregate expenditure will be A bar plus marginal propensity to consume multiplied by disposable income. So let's get a numerical example. Let's assume that we have a consumption that's composed of autonomous consumption of 1,000 and the marginal propensity to consume is 0.75 multiplied by disposable income. We have autonomous investment of 300. We have autonomous government spending of 500. We have autonomous exports of 250 and autonomous imports of 50. So if we'd like to draw our consumption function, So I will get here our x-axis, which is disposable income, our y-axis, which is our consumption. I will start here with our upward slope consumption function, which is 1000 plus 0.75y, and I know that the intercept here is $1,000, and the slope will be 0.75, which is our marginal propensity to consume. Then I would like to calculate our autonomous spending, our A bar. So our A bar is equal to C bar, which is 1000, plus I bar 300, plus G bar 500, plus X bar 250, minus M bar, which is 50. This will give us 2000. Then I would like to calculate our planned aggregate expenditure. So it will be A bar plus little c, which is our here 0.75, multiplied by disposable income. So I will tell you, if our disposable income is $1,000, so what will be our planned aggregate expenditure? So it will be 2000 plus 0.75 multiplied by 1000, it will give us 2750. What if I double our disposable income from 1000 to be 2000? What will be our new planned aggregate expenditure? So it will be 2000 plus 0.75 multiplied by 2000. By substituting in our formula, this will give us 3500. So let's draw it and put it with numbers. So I will get here, this is our x-axis, which is our output, and this is our y-axis, which is our planned aggregate expenditure. I will draw here our output, which is equal to our aggregate demand or aggregate expenditure, and that's why I will make it 45-degree line. And then I will draw here our planned aggregate expenditure or aggregate demand function, which is A bar plus marginal propensity to consume multiplied by disposable income, and the intercept here is our autonomous spending. So both curves intersect at one point, which will give us our aggregate expenditure is equal to our output. Therefore, let's do it mathematically using our formula. So this is the formula of planned aggregate expenditure, which is autonomous spending plus marginal propensity to consume multiplied by disposable income. At equilibrium, I know that our output will be equal to planned aggregate expenditure. Therefore, our y will be equal to A bar plus little cy. I would like to put all y's in one side, so I will take cy and put it the other side by changing the sign. So I will get here y minus little cy equal A bar. I would like to get y as a common factor. So I will get here y multiplied by 1 minus c is equal to A bar. Then I would like to divide both sides by 1 minus c because I would like to put y on one side, all other variables in the other side. So y is equal to A bar multiplied by 1 over 1 minus c. So 1 over 1 minus c. This is called the multiplier. Some textbooks, they give it a symbol of m or k or alpha. So I know that the multiplier is 1 over 1 minus marginal propensity to consume. Therefore, our output level at equilibrium, which means our planned aggregate expenditure is equal to our output level. The formula will be A bar multiplied by the multiplier. So building on the previous example that we explained, we have autonomous spending of 2000, A bar equal 2000. We have marginal propensity to consume is equal to 0.75 or 75%. Consequently, the multiplier will be 1 over 1 minus MBC, which is 0.75. This will give us 4. Therefore, our output at equilibrium will be our A bar multiplied by the multiplier. Therefore, I will get 2000 multiplied by 4. This will give us 8000. So let's draw it in our graph and put the numbers instead of symbols. So this is our x-axis, which is our output. And I'll put here 2 dashes, which means I don't start with 0. And this is our y-axis, which is planned aggregate expenditure. I put 2 dashes because I don't start from 0. And this is our 45-degree line where our aggregate demand or aggregate expenditure is equal to output level, and that's why it's 45-degree line. And this is our upward slope planned aggregate expenditure. We know that our formula is 2000 plus 0.75y. So I know that here our intercept, which is the autonomous consumption, is 2000. And here our output will intersect with planned aggregate expenditure at one point. This will be our equilibrium point. From our previous calculation, we just calculated as 8000. So when we use fiscal policy, we mainly talk about taxes and we talk about government expenditure. Therefore, in order to stabilize the economy, if we have a recession, we need to use an expansionary fiscal policy, which means we need to increase government spending or decrease taxes. Or if we have growth, or we have upturn, or if we have a recovery, or we have an expansion, we need to use a contractionary fiscal policy, which means lower G and higher T. So what I will do now is I will give you an example of increasing government spending and another example about decreasing taxes to see what will happen to our economy when the government inject more money or decrease tax or give a subsidy. So these are the values that we calculated earlier. So I will tell you what will happen if we change government spending by 100, which means we increase G by 100. So our simple formula will be is the change in Y will be equal to a change in A bar multiplied by the multiplier. So our change in A bar will be equal to the change in G. Therefore, I know that the change in our output will be equal to 100 multiplied by 4, it's equal to 400. So as you see, we change government spending by only 100, while our output will change by more than 100, which is 400. Why? Because we have a multiplier. And this is the effect of the multiplier. Therefore, what will be our new output? Our new output, which is Y prime, is equal to our old output plus a change in output. Therefore, it will be 8,000 plus 400. This will give us 8,400. There is another way to calculate what's the change in output if we change one of the components of our aggregate expenditure formula, either C or I or G or X or M. So the other one is we need to calculate our new autonomous spending, the new A bar. So get A bar prime is equal to our old A bar, existing A bar plus the change in G. So our A bar is 2,000 plus government expenditure will increase by 100. So this will give us 2,100. Then our new output level will be our new autonomous spending multiplied by the multiplier. So I will get A bar prime multiplied by the multiplier, which is equal to 2,100 multiplied by 4. This will give us 8,400. As you see, we get exactly the same answer. So our output increased by how much? I will get the change in output is equal to our new output, Y prime, minus old output, which is Y. This will give us 8,400 minus 8,000. This will give us 400. So let's reflect it in our graph. So anytime we talk about planned aggregate expenditure here we have an intercept. Anytime we will change the intercept, which is A bar or any component of the A bar, such as C bar or I bar or G bar or X bar or M bar, this would result in a shift. If A bar will be higher, so I know that it will shift upward. If A bar will be lower, I know that it will shift downward. Anytime we change MBC, this would result in we change the slope. Consequently, it will be a rotation. It would rotate. So let's do it. This is our x-axis, which is y. We put two dashes because we don't start from 0. And this is our y-axis, which is our planned aggregate expenditure. We put two dashes because we don't start from 0. This is our 45-degree line where our output is equal to aggregate demand, and that's why we draw it as 45-degree line. And this is our original planned aggregate expenditure, which is equal to 2,000 plus 0.7y. So the intercept here is 2,000. And this is our equilibrium point where we have an intersection between y and planned aggregate expenditure. And here this will give us 8,000. Then, because our autonomous spending increased by 100, because the government expenditure increased by 100, so I know that our planned aggregate expenditure will shift upward. Therefore, our new intercept here will be 2,100. We will have a new point of intersection between the new planned aggregate expenditure, that's why we can put here as a prime, and our output curve. At this point, we have a new output level of 8,400, which is equal to aggregate expenditure at this equilibrium point of 8,400. So I would like to explain now what we mean by the multiplier. Like we talked about the multiplier, we defined the formula, we calculated this one. So I will tell you, let's assume that if we increase G based on this formula, and this is equilibrium, which means our output is equal to planned aggregate expenditure, what will happen to our output level? Our output will be higher. So if I increase G by 100 billion, for example, what will happen to our output level? It will increase by 100 billion, or more than 100 billion, or equal to 100 billion, or less than 100 billion. I know that the correct answer, it will increase by more than 100, because in the example that we give to you, it was 400. And this is what we call as a multiplier. So, can we explain the multiplier in easy words? Yes. Let's assume that the government would like to buy roads, tunnels, and infrastructure. So they need to hire labor. They will give labor wages. Once they give them wages, this labor will go to businesses in order to buy goods and services. These businesses would like to produce more in order to meet this extra demand. Therefore, they need to hire more labor. If they hire more labor, they need to give them wages. Therefore, these people will take these wages and they will go to businesses, to shops, in order to buy goods and services. Therefore, for these companies, in order to meet the extra demand, they need to hire more people. So by hiring more people, they need to give them wages, and then these people will take the wages in order to spend it, and so on. Consequently, we discovered that the effect of this $100 billion is much bigger on our economy, because we started to stimulate the economy, and that's why we call it the multiplier effect. Therefore, if we'd like to draw it, it would be like this is barrel effect. Which means, yes, you start with 100, but you end up with more than 100, because you stimulate the economy. And vice versa, by the way, if we start to decrease any component of the aggregate demand function or aggregate expenditure, you'll discover that it will go the other way. It will shrink the economy more than our reduction. For example, if we decrease our government expenditure by 100 billion, our output will shrink by more than 100. For example, it will be 400. So our second example will be reducing taxes or giving more subsidy. And we'd like to see if a government decides to use a fiscal policy to stimulate the economy because we have a recession, either by increasing government expenditure or decreasing taxes, would we have the same effect on our output level or a different effect? Let's check it. Now, I would say that we have a reduction in taxes by 100 billion. Therefore, what will be our change in output from our formula here? I will get a change in A bar multiplied by the multiplier. So I know that when we decrease taxes by 100, it means that our disposable income will increase by 100, but we're not going to spend the whole 100. We just spend it based on our MPC, marginal propensity to consume, which is for each additional dollar of income, how much we're going to spend of this one. Therefore, I need to get here a change in T multiplied by marginal propensity to consume multiplied by the multiplier. Therefore, our change in output will be 100, which is the change in taxes, the reduction in taxes, multiplied by our marginal propensity to consume 0.75, multiplied by the multiplier 4. This will give us 300. If you compare this one with our government expenditure, when we increase government expenditure by 100, we discover that our change in output was 400. Therefore, here, when the government uses a reduction in taxes to stimulate the economy, it will have a lower effect compared to using government expenditure. Why? For a simple reason, because when you give more disposable income to people, they're not going to spend 100% of it because they have savings. Therefore, our new output level will be y prime is equal to our old output plus change in output. So this will be 8,000 plus 300. It will give us 8,300. We can do it another way by using our output formula. So this means that here I need to calculate our new autonomous spending. So our new autonomous spending, A par prime, is equal to A par plus a change in taxes, which is the reduction in taxes, multiplied by marginal propensity to consume. So this will be, we have here an old A par of 2000, plus we have a reduction in taxes of 100, multiplied by 0.75. This will give us 2075. Then our new output level will be our new autonomous spending multiplied by the multiplier. So I will get here 2075 multiplied by 4. This will give us 8300. Both methods will give you the same answer. Now, if I'd like to know what would be our change in output, so our change in output will be our new output minus old output, which is equal to 8300 minus 8000. This will give us 300. So I know that because of the multiplier effect, if we reduce taxes by 100 or if we give a subsidy of 100, I know that our output will increase by more than 100, which is 300. So if I would like to reflect it on the graph, this is our output level and this is our planned aggregate expenditure. This is our 45-degree line of output, and this is our original planned aggregate expenditure, which is equal to 2000 plus 0.7y, and this is our intercept, which is 2000. Then because of reducing taxes by 100, I know that our autonomous spending will increase, therefore it will be upward shift. So here we get the equilibrium, which was 8000, the original one. Then here I know that it will shift, and I can write it here as a prime, our new planned aggregate expenditure. So here it will increase to be 2075 plus 0.7y. So I know that the new intercept here will be 2075. And then we have a new equilibrium point between the new planned aggregate expenditure and our output level, this point. So here we'll have 8300, and here we have 8300. So when we talk about expansionary fiscal policy, we said either we increase G or decrease taxes. So if we're going to increase G by 100 billion, or if we're going to decrease taxes by 100 billion, I know that the effect on the economy will be different. For both of them, we have a multiplier of 4, but we discovered that if we increase government expenditure by 100 billion, the effect on the economy will be 400. While if we decrease taxes, I know that the change of our output will be 300. So both of them would result in a higher output, more than the 100, but with taxes, it will be lower than government spending for one reason, because we have savings when we give more increased disposable income to household. Therefore, let's draw it. This is our inflation, and this is our output level, and this is our aggregate demand. So if we're gonna, based on the Keynesian model, we know that if we increase government spending, so the change in output will be bigger than the change in government spending, which we call the multiplier effect. So I know that our aggregate demand will shift to the right. This is equivalent to a change in government spending. For example, if we're going to increase government spending by 100, so I know that aggregate demand will shift to the right by the amount of this 100. Then it will shift again further by more than 100. Why? Because we have the multiplier effect. So here we have 100, for example, and this one was 300, so the total effect was 400. But based on the classical model, they said that Keynes usually overestimate the effect of the multiplier. Why? Because if government spending will increase, this would result in a higher inflation. Based on the higher inflation, it would result in a higher interest rate. Higher interest rate will hinder investment. Investment will decrease. Therefore, we discover that the government is crowding out businesses in order to get the liquidity from the market. That's why we call this negative relationship between higher interest and lower investment as a crowding out effect. Therefore, I know that increasing G will increase output, but at the same time, it will decrease investment. Therefore, our aggregate demand will decrease and it will shift backward here. And this is mainly because of the crowding out effect. Therefore, our net effect will be this one. So this is the joint multiplier and crowding out effect. So this is the effect after we take into account the multiplier effect, which over-exaggerate the effect of the multiplier, and the crowding out effect. Therefore, the total effect here will be from 80 till 84. And this is the total multiplier effect. Therefore, we said this one is 400. Therefore, this one will be actually less than 400 because we didn't take into account the reduction in investment, because increasing government spending, which results in higher interest rate. There is also another factor, which is we have a time lag. Therefore, do you think that any time we increase government spending, do you think that the output will increase immediately? No, we have a time lag, and that's why we need to take this time lag into account. Consequently, some governments could destabilize the economy because they over-exaggerate the effect of the multiplier, and at the same time, they don't take into account the time lag that we have when we implement an expansionary or contractionary fiscal policy by changing government spending, taxes, and subsidy, because it takes some time to have an impact on our output. Therefore, we prefer to have something called automatic stabilizer. So automatic stabilizer simply means that we should have a system that implemented changes in fiscal policy in order to stimulate our aggregate demand anytime our economy slows down and we head into a recession without policymaker having to take any deliberate action, such as using a tax system. Anytime we go into recession, taxes will decrease. Or we have unemployment benefit. We have a subsidy system. Therefore, the economy will stabilize itself by itself using this kind of automatic stabilizer. So this is our output level. This is our planned aggregate expenditure, and this is our 45-degree line where aggregate demand is equal to our output level, and this is our planned aggregate expenditure, and this is our equilibrium point where our output intersects with planned aggregate expenditure. Let's assume that we have an output level below our equilibrium point here. So which point is higher, planned aggregate expenditure or output level? So as we see here, our planned aggregate expenditure is bigger than our output. Consequently, we consume more than what we actually produce. So what will happen to our existing inventory? Our inventory will go down. So if inventory will go down, do we have a motive to increase production or decrease production? Increase production. Therefore, we will keep increasing our output till we reach our equilibrium point. What if we have an opposite scenario where we have a point above our equilibrium point at Y2 here? So if we check which point is higher, our planned aggregate expenditure or our output level? So as we see, our output level is bigger than planned aggregate expenditure, which means we produce more than what we actually consume. Consequently, our inventory will be higher because we couldn't sell this part. Therefore, we will store it as an inventory for next year. Therefore, next year, do we have a motive to produce more or less? Produce less. Therefore, our output level will decrease until we reach equilibrium.